quadrilateral with exactly one pair of opposite sides parallel. All right, so we have one pair of opposite sides parallel. So when you have this, you know those two sides, and only those two sides. Now on a trapezoid, we're going to get more specific with the names, but those are called the bases. You can have them, you know, standing up, different lengths of legs, but the two sides always have to be parallel to each other. So don't forget when you're working with that. Sometimes people just forget when it's drawn. They won't be that way. So that's a trapezoid. It's a quadrilateral with exactly, don't forget this word, one pair of opposite sides parallel. So it'd be huge. And the next one is very specific, an isosceles trapezoid. Now think about that. When do I have an isosceles triangle? I have an isosceles triangle when I have two congruent sides, or at least two congruent sides. Well, with the isosceles trapezoid, you're going to have congruent sides again. Now, when are those? An isosceles trapezoid is a trapezoid whose non-parallel opposite sides are congruent. So what example is that? Right here. Those two have to be the same. Now the cool thing is we'll study later, especially second semester, all these cool properties that happen with the isosceles trapezoid. Now this is just an organizational chart of the different quadrilaterals we just learned. Let me put it this way. This will show up again. This exact same chart will show up on your quiz. Actually, I shouldn't say quiz. Test coming up. All right, so it's the test. So no chart with definitions for test. This will show up again. So this one just kind of gives us the basic ideas that you have to have, okay? So first of all, we have the basic. We start with the all-encompassing quadrilateral. I know it has four sides, but notice, where do I go here? This one has no parallel sides. So this is like the branch with no parallel sides. So what do we have first? That's right. We have the kite. So in a very specific example of no parallel sides would be a kite. Well then, what would this one down here be? This would be one pair of parallel sides, would be this branch, which means then we'd have our first one, a trapezoid. You have to have at least one pair of opposite sides parallel. Actually, only one pair of opposite sides parallel. Then coming from there, we'd be more specific. We'd have an isosceles trapezoid. Now, for some reason, when people fill this out in the past on their test, they get the isosceles trapezoid and regular trapezoids confused. Remember, the isosceles trapezoid is a very specific case of a regular trapezoid. So go from more general to more specific definitions. Then our next one we have is when we have our branch is the two pairs of parallel sides. And what's the most generic name for a parallelogram with two pairs of parallel sides? That's right, it's going to be a parallelogram. So we have our parallelogram. Then we go to the one with right angles. Okay, so when we have four right angles, what type of figure is that? A rectangle. And then we have our side over here, our figure with four congruent sides, which is going to be our rhombus. And if I put the rhombus and the rectangle together, what do we make? That's right. We're making a square. So it kind of shows you how these are being formed. It kind of gives you a graphical way of organizing it. So let's go ahead and let's do an example of using previous information that helps us classify these very specifically. It says determine the most precise name for the quadrilateral with the given vertices. You will need to use slope and distance formulas. So I very specifically told you the reason why I need to know slope is so I know the opposite sides are parallel or not. Because if they're not parallel, then I know right away I can throw some of these out up above. So I'm going to do a quick graph over here of my x and y axis. Here's my x, here's my y. I'm going to put w down first. That's at 0, 5. So 1, 2, 3, 4, 5. And we have x is at 3, 5. Y is at 3, 1. and z is at 0, 1. All right, so here is a quadrilateral. Now what should that look like to you? That should look like it's probably a rectangle, right? So let's double check to make sure that's the case. Let's do slopes. Now you should be able to give a visual slope if they're horizontal or vertical lines, all right? So the slope of segment here, WX, is equal to 0. Now how did I get that? Well, remember, it's the change in y or the change of x. So really it's 5 minus 5 over 3 minus 0. Well, 0 over 3 equals 0. So we know that's the case. So that's also the slope of ZY, because it's another horizontal line. Then we have our vertical lines. Remember, vertical lines are undefined, but let's just calculate one to do a quick remember when. So we know the slope of segment WZ. Okay, change in y. All right, so we're going to have 5 minus 1 over the change of x, 0 minus 0. Oh, look, 4 divided by 0. Are we finished? I'm hoping I'm hearing some resounding no, 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 no's. Because if I divide anything by 0, that is undefined. All right? So that also then means for our slope, segment xy would be the same thing. It's also undefined. Now here's some good news. Because we know that they are undefined, these two are parallel, and these two are parallel. And we know that they are undefined in 0. We also know that they're perpendicular. So right away, you should know that's a rectangle. I don't even have to calculate the side lengths, but let's double check to make sure we know calculate the side lengths with this. Our distance formula, which is x2 minus x1 squared plus the quantity y2 minus y1 squared, we're going to plug it in to find the different segments. Now, I'm going to do just, again, example of 1, because these are horizontal and vertical lines. This is when counting is actually faster than using the formula. But let's go ahead and let's do WX first. The length, or the distance, and we're going to use WX, is going to be the change of x squared. So I'm going to go 5 minus 5 squared plus the change in y. So I'm going to go 3 minus 0 squared. So I'm using these vertices, and I went this direction. So I get 0 squared plus 3 squared. Well, 0 squared is 0, so I'm not going to use that. 3 squared is 9. That equals 3. So WX is 3. Now, you'll find out the length for the other ones are going to be the same thing. ZY, 1, 2, 3. Now, you can do the same type of idea. I'm going to do the counting process. Let's just say for WZ, because they're vertical lines, I can do it real quick. 1, 2, 3, 4. XY. 1, 2, 3, 4. So we know the opposite sides are congruent also, but they're not all the same size, so I know for sure it's not a square. Our most specific name we can get is going to be a rectangle. But notice we just used the process. We used slope to tell me things are parallel or not, or even perpendicular, and we used the distance formula to find the length of the sides.